Neil from Essex here to take you along on part 3 of a tour that we did through the HydraForce facility in Chicago. This video is going to be focused on the engineering process, the R&D and development that is done in order to kind of engineer these hydraulic brains that operate your equipment. I'm going to take you along, show you some of the facilities, the work that these people do to go through and really make sure that they're making the best quality product possible for you. I thought there are a lot of parts of this tour that are particularly interesting when it comes to the steps that are gone for testing things with dirty hydraulic oil, or the conversations that we were able to have here about a component's manufacturer's place in the warranty cycle, that life cycle of your machine. A lot of interesting conversations to be had. Join us here on a tour through the HydraForce facility.
Essex, a helping hand with your land.
So our engineering lab used to be in our first factory, we call P1. And it was just running out of room, running out of capacity for, heat exchangers, running out of power. And so we really moved into this facility for this area right here. And you can see, I think we more than doubled our capacity to test product because we're developing new products all the time. And when our bottleneck becomes what we can prove out in engineering test, that was limiting our capability of getting stuff to market faster. So this whole area, a lot of new test stands. We went from just air cooled to water cooled. So you see a lot of piping going up here. Chilled water is on the roof actually of this facility. So a lot of our customers will want to, they have to make the machines operate in temperature ranges from like -40 to like 100 degrees plus, right? And so they have their own chambers in their engineering areas where they can test machines, right? But the problem is that testing takes a really long time for them. And so the queue, there's a huge queue, right? So engineers will come to us and say, well, how will this valve operate in really cold temperatures? Because that's really the biggest variable when viscosities of oils are really high. So this is a chamber where we can regulate the temperature of a full test stand, like a reservoir and a test stand. So we can actually do a test of a sub-assembly for them in this chamber, and that gives them a lot of knowledge before they get into their test bed for their cold testing.
Of how that's going to perform.
Yeah, exactly.
So you're taking then like their spec for the hydraulic oil and everything and using their fluids through their essentially valve. And cool.
Yeah. It's kind of an accelerated life cycle testing.
Yeah.
Kind of.
Well, it's important because they need to know how's that. They can't have. They can only have a certain level of degradation, right? Because if you're an operator, you jump in the seat of a vehicle and you want it to operate, you expect it to operate the same regardless of the temperature, Right. You can probably understand at -40 that it's going to be a little sluggish, but it still has to be able to operate, and so that's what this is for, and it helps speed up their engineering process and get to production quicker with new products. So that's a pretty nice investment for us as well. This is some 3D printing that we have. So. This one's for metal, though. We actually do 3D printing for metal parts. So like we can 3D print custom fittings or custom tools or for manufacturing. That's mainly what we're using for it right now. We're not really 3D printing anything for hydraulics yet, but we've experimented with the manifolds. Like those manifolds are just machined from aluminum, extrusions or Durabar material. But we're experimenting with maybe some blocks that would be additive manufactured.
So where you can basically do all kinds of crazy porting and stuff internally because you're building it from the bottom up.
And you can make it smaller in most cases, right?
Yeah, so it's that additive manufacturing that you can optimize whatever the piece you're trying to make, and that you couldn't make through traditional machining means you can do here. But it's the market time, and I'm getting that message in a big way, is market time to get prototypes or new concepts to the customer is really key. And so we're working on how do we get things to the customer quickly, concepts, prototypes, pilots, right? So this helps us do that.
So at this point, I mean, is anything able to hold the pressures of a hydraulic system at this point?
So we have experimented, but you know, there's different hydraulic systems. Some of them are lower pressure,
okay.
Like for instance, pilots and clutches and stuff like that. And then some of it's the high pressure stuff. Like what you're seeing built out there is mostly high pressure stuff. But the low pressure stuff so far, it can be used in.
Okay.
But it's the cost per piece that's still being worked through.
So the way this works is, you know, you have a model, right? And it uses it's like a powdered metal.
Right.
It's kind of like a carbide, if you know anything about carbide. And there's like a polymer that keeps this thing together, or a binder that keeps the thing together. And it builds this thing up based on the model until you have your finished product. Then it goes into an oven and gets sintered.
Yeah.
So it's a high heat that's where you get your strength of the material. In terms of, so to Russ's point, we haven't really done any blocks yet. We haven't done any manifold blocks. We're doing like little pieces and components of stuff right now in the metal printer.
So nothing is actually a production run part at this point. This is still
correct.
Yeah, this whole area is all engineering experiment lab area.
Yeah, for when it's ready.
Over here, this is our environmental lab. So this is what I was telling you about, you know, the integrity of coils in electrohydraulics. And so we've got these environmental chambers. We've got freezers. You can see there's some coils in there. You can see the wires hanging out. We've got different over here. You can see this is a salt spray tester. You know, so we've got all sorts of different ways of testing the coils. You can kind of see, here's an example of it, right? You know, these went through a barrage of tests, and we continually test them, you know, to make sure that the supplier's meeting the specification. So it's kind of a continuous thing we do in order to guarantee that the coils won't fail. That was a really big issue for a while, you know, like for us, because we're the key to our product, and really the bread and butter is that coil solenoid proportional valve. And if the customers aren't feeling confident with it, and if the customer's customers aren't confident with it, then it's not going to move forward. You know, it's almost kind of like this trend towards electrification, you know? Like if the customers aren't comfortable with 440 volt or 800 volt machines, you know, it's going to reduce the amount of times they can get those sold to customers. So so this was critical for us, and that's why we had this whole area and did it all ourselves.
Simple as it is, you got a metal coil inside of a plastic housing that are going to expand at different rates when they contract. Right.
And then you know, what you have to do is make sure, first off, that this doesn't crack under that stress.
Right.
But also that even within the knit lines and through the connector even too, that you don't get water sucked inside. Because if you get water sucked inside, then that's when it's going to fail. Yep. And so, you know, I don't know how, most guys, when they take a machine and they wash it down, they high pressure wash it, right?
Yes.
So they're taking a high pressure water at a certain temperature. Let's say the machine just finished working, and the guy and so the coils are going to be hot, the whole machine's going to be hot, and they're probably cold water because it's first coming out, right? And it's high pressure. So it's almost like shocking the coils, and it's also through these like little possible areas where the gaps where it could get in, like the connector, right? And you're trying to shoot water almost in there, and so we have to prevent that. And we come up with technologies to do that. So
yeah, I mean, you're testing that scenario effectively.
Yeah,
because we all know, as much as we tell people don't do it.
Yeah, exactly. You know, that they do it.
It does. It happens.
Yeah.
That's cool. So I mean, that's it. A room of stuff to simulate you pressure washing your equipment inappropriately.
We have a group of manufacturing engineers. They got to figure out why did this thing fail, and with all the interactions of all the pieces of the valves that we talked about, you got to do a lot of forensics sometimes to figure out why something's failing. And so Syed here in the lab, he's got some light machine tools to do work where it comes to R&D. So he was showing me down here, and this just blows me away, but when you talk about like cycle testing and how we validate our product, this blows me away, and I still can't wrap my brain around it. But when we test a valve, we cycle it at pressure, and most times not at pressure. We go beyond the spec, our published spec on that valve at 1 million cycles. And sometimes we go beyond.
We have some that are 10 million, like on valves that go in transmissions, stuff like that. 10 million cycles.
So when you think of 1 million cycles, and you know, and if it fails before that, we go back to the drawing board. You know? And so, you know, the valve may perform beautifully, but you know, it fails prematurely.
So that's a question then. So in my world, when we have a warranty claim for a valve assembly like this, many times the manufacturer will ask for those parts back. We have a shelf time that we have to keep warranty parts on the shelf in case they get asked for. So when I'm returning parts to the manufacturer, do they eventually, in some cases, make them back to you?
Oh yeah, for sure. Yeah.
Okay.
We need that to troubleshoot the issue.
Yeah.
Right.
Yeah.
And you know, so the forensics of troubleshooting an issue, you know, and sometimes those field failures help us understand maybe an inherent flaw or something, or something that happened that was very specific to a certain time or a date, or you know, all that is it's like a CSI project. It really is.
I hear that in these contexts a lot of manufacturers make a machine, you guys make a parts, and then losing touch of what happens to that beyond that in the ownership experience. Right.
Yeah, you know, I think it's an interesting question, because that's one of the struggles that we have, is the inability to get those parts back.
Yeah.
Sometimes it's really tough to get the pieces back, and sometimes I think maybe it's just as simple as they don't understand why we need it.
Yeah.
So it's kind of a pain in the ass. So why do you need it? And, you know, but it's critical that we have those parts back, even if it's in 10 pieces.
Right.
It's important.
Our customers, the OEMs, they keep making the demands on us and themselves too for the machines to last longer.
Right.
Okay. So like, you know, they'll have a life, you know, however many hours, 10,000 hours, 15,000 hours, 20,000 hours. It just keeps getting longer and longer, right? And they're all doing it. And so, you know, if a part fails prematurely in the field, you know, one time they may just say that's okay. 2 times, 3 times, they start to say, hey, wait a minute, we need to figure out what's going on, and then they get it back to us, and we have to really fill out a lot of paperwork and do a lot of, like Dan's saying, like a CSI investigation, and really provide them with the results of what's going on from our standpoint.
So that comes back to a lab like this, basically, where they start tearing it down and figure out.
Well, we have a lot of, so, you know, over at the plant one in the production, we have a lot of mechanical engineers, where those forensics are a big part of their job. We have, you know, we have quality engineering as well. We have a warranty group. So we have, you know, when you think about it, we have a lot of technical resources that support not only the development of new products, but the, you know, the continual quality of our existing products throughout the process. Right. And with our warranty, as far as I know it, you know, we have the best warranty in the business.
So you're providing a warranty to the companies that you're selling the parts to. Okay. So when again, going back to my business relationship with my suppliers, when I make a warranty claim with them, many times they're just basically turning around and then handing that back to you to pay the bill.
It depends. It depends on you know what the failure is. Yeah, exactly. Like, because we can't control everything, right? Like our valve, like if a pump fails, let's say, or some, you know, contamination gets in. Usually our valves end up being a really good filter for when that happens. And so then then you know, then they say no, that's on us, or it's on somebody else, you know.
But conceivably you can see that.
Yeah, if it's truly our problem, if there's an error in manufacturing, you know, and in the product that we supplied to them, then yeah, we support that.
It's just interesting if there's skin in that game the whole way down to your.
Oh, it's all the way down, even to our suppliers too. It goes back there. Yeah.
So that's you know, we have a very knowledgeable warranty group. So when something gets returned to us, there's an initial vetting of that, because a lot of times when a customer sends it back, they just know it doesn't work. They don't know why. And to Russ's point, you know, it could be they installed something incorrectly, they torqued it incorrectly, they replaced something incorrectly. It could be a number of reasons. So sometimes what we do is we'll repair it and send it back. Now that's not the business we want to be in.
Right.
You know, but at the end of the day, I would say we make it a very fair assessment, and we err on the side of the customer. And we make it right. So
that's pretty much it. Yeah. We
so
stand
this
behind
was
the product.
what he's doing here is he's testing the longevity of a spring. So we have springs in a lot of our valves.
Almost every valve has a spring.
I mean, spring is a big one. So he's life cycling a spring with this. This has been going since the beginning of July, and he's cycled 4 million so far.
Yeah.
So I mean, my point is, like, we take that for granted, but I mean, when you think about it, you know, the level of life cycling that we do here is so critical to the performance of our valves.
So what we'll do in some cases is a customer will have a new machine that he's developing, and he'll bring it in here. Like, there's supposed to be a log splitter in here somewhere, but yeah, there it is right there. So there's supposed to be, you know, they'll bring it in here and have us work on it, or we'll rent machines, right, to do some testing on, or we'll buy them, you know. And so like this telehandler we bought, and you can see we painted it all the HydraForce colors, right? And what we did here is I think we removed the traditional hydraulics that were on it, okay? So yeah, you can see here, looks like they got lights set up for you and everything here. Yeah. So we removed the traditional hydraulics that were in here. There was like a regular spool valve, and we put in place a cartridge valve assembly. And you can see here too, we've got a couple extra, this is our partnership with Roquette again, where, you know, we've got a couple auxiliary functions that are spool but directed by our proportional valve there, right? And so this is a different circuit logic than the industry is used to, okay? And it also has something to do with how we proportionally control on the cylinders themselves. And we just do this to demonstrate. And one of the things we're demonstrating here is fuel savings, potentially, and actually ease of control ability, and that's productivity. So one of the things we can do with this circuit is we do what's called gravity down, gravity lowering. And so we've even demonstrated if, in this case we didn't install it, but if you had a run-stop engine, let's say, on this vehicle, you could run it when you're extending and lifting up material to the construction site, and then when you're lowering, you could turn off the engine and you could just gravity lower down very smoothly, very quickly. And actually the other thing is, when you're gravity lowering, if you have the engine running, and they'll gravity lower and retract the boom, you know, that you can actually retract the boom faster, because you're not using hydraulic oil to lower. You're just letting gravity lower it, and you can use that oil you're not using to retract faster, so it increases your productivity.
So that has potential application too in like electrification of this stuff, right?
Yes.
So yeah, right, you're only having then to use power to push and not allow that to fall back.
Yeah, exactly. And so like this is sort of future technology. Again, nobody's buying this. You know, it's kind of like the skid steer we're gonna look at. Yeah. This is nobody's buying it, but we put it on this machine. We demonstrate it. This machine also has one of our controllers on it, which is that remote access telematics controller. So at Con Expo, which was that was before the pandemic in 2020.
Right in the middle of the
March of 2020.
Yeah. They all came back and then they quarantined, right?
Yeah, we can actually control this, you know, from say Las Vegas. We could control the operation of it, like put it into an expert mode versus a beginner mode. We can collect data off it. We can reprogram it. We could do, you know, we could send updates to it. So we could do that from Las Vegas in our booth when we were demonstrating that.
So it's cool. This is to my eye, a used machine then.
Yes.
You bought it used and totally re-engineered the way that it works.
Yes, exactly.
As a sales tool.
Yeah, exactly.
Essentially.
Yep. Because we just feel like there's no better way to demonstrate our capabilities to our customers than to do some of this sometimes.
Right.
You know?
Yeah, so interesting in that, like, it's not just the manufacturers deciding they want a new feature. In some ways, you guys are actually showing, here's what can be done, guys.
We try to listen to what the markets are saying and what are they requiring.
Yeah.
And because our customers, you know, they're going to hear that same thing, and they're going to come to us and say, hey, I need this. And then somebody's going to have to step up and, you know, say, well, I've got the technology to do that.
Right.
And we want to be the one to be able to say that.
Well,
and the only way we can do that is if we experiment and we try different things and we can demonstrate.
Yeah, you can be the guy that says, here's what we've already got.
So like if they want to do gravity lowering at some point, we come in and we say, hey, yeah, we can do it. You know, and we show them the results. Like we show them the fuel savings, we show them the productivity gains. While we have to send very clean product to the customer, to our OEM customers, it has to survive in even contaminated oil. So what we do here is we actually take our products and we introduce contamination on purpose, and we run the valves We'll turn them on and off. We'll keep running them until we see like what's the actual limitation, like when do they fail, right? And so then when customers come to us and they say, hey, well, how will it operate in this kind of environment? We're able to tell them.
Yeah.
And we can even, if they ask us to do a special test in a certain level of contamination, we can do that. So that's what this test stands for.
I think your data point there is really interesting because we would often coach our customers a little bit on caring for your machine when it's aged.
Yeah.
Right? Because you get to that point, whatever, the thing's got 3,000 hours on it, I don't want to put the time and the effort into it anymore.
Yeah.
And you would see the real world of that, of mechanical breakdowns and stuff that happen because we're not being as careful.
Yes, exactly. Because we call it the wash tub effect. So it's at the beginning of the life and it's at the end. And it's at the end, the filters can only collect so much debris.
Yeah.
And depending upon the filter and where it's located, if it has a bypass, that's the worst thing. The other thing is the tanks, right? The tanks, they collect contamination over time. And then depending upon the level of the oil in the machine, right? That slurry, that oil can become more contaminated and you're sending it through and it's just wearing down the parts. And eventually, it could cause a seizure where, the spool doesn't move anymore. That piece of contaminants caused a problem. And now you're right. It's a lot easier, I would think, if I'm an operator, to have a piece of equipment in a bay at a dealer or on my construction site with time to work on it and make sure that it's got clean oil and a good filter and everything, versus being in the middle of a job and then all of a sudden have a spool seize up because of a piece of contamination. Now you can't use the piece of equipment.
Yeah, I mean, we're continually encouraging that good oils, changing your filters regularly and all that kind of stuff in your machine, even at age, right? Because you have this perspective of, well, this thing's all beat up or it's not worth it anymore or whatever, and that's when people start doing things like not changing their filters regularly or buying maybe not the right spec filter or running a hydraulic fluid that really wasn't supposed to be there. And that causes the bathtub.
Yeah, exactly. Yep. And so that's why we run tests here to see if we can survive. How long can we survive?
Right. Yeah, make the bathtub as long as possible.
That's right.
We pretty much have every capability within the building to make what we need to make. Not in capacity wise, but like we have soft turning. So, we do turning, we do OD, ID grinding, and then obviously we do HMC. So what you'll see out there is you'll see a lot of grinding as well, that we do finish grinding for, poppets and spools and different types of components like that. How you doing, guys? Good. So this is our CNC department. These are two horizontal CNC machines that we have. We mostly do prototypes. That's what these machines were intended for, but they've gotten converted very quickly to production in this supply area. What are you guys making today?
Prototypes.
What do you got? This one?
Yeah, I haven't started on it. I just ran the first piece, but yeah, it's gonna be in production tomorrow. And over here we got another prototype, the model 2. Pretty tight tolerance, plus minus 2.5 times.
Oh, I know. Oh yeah. Yep. This is a brand new valve we're working on today. Yeah, it's snowmobile shock absorber.
That's right. So what we're doing, this is one that we talked about, the rapid prototype program that we're putting. We wanted to work on this. So we're trying to get a certain application into a particular envelope.
Right.
It's kind of new. This is brand new stuff. So this is where we do the inspection of our blocks. So there's quite a bit of inspection that goes into the first piece that we make. We have a Zeiss small axis CMM machine. These things they're quite precise. Give us the ability to inspect everything we need to on our blocks.
Yeah.
It's a $1 million test stand, and all the cooling on the top that's why it's so big. But this is all our high pressure stuff. I think we're testing at 8,000 psi, up to 8,000 psi. It has two sides. It has two different pumps. So some valves we don't have that high pressure. So we created an ability to separate the two pumps so we can test 2 valves at one time. So if it's a lower pressure, we can test 2 valves on this side. If it's that max pressure, we can do 1 at a time on the other side. So it's either or.
Right. When you look at the market, you continue to see higher pressures, more flow, presumably at those pressures.
Yep.
Yeah.
And this is what it takes to
offer that product.
offer that product, right? Is something that can test at that level.
Yeah, exactly. Like the pressures are actually higher in Europe for the most part, and so the North America is just catching up to that, you know, and then it's going to keep going, I think. Yeah. And the way hydraulics is going with electromechanical devices as another option for people for motion control, you know, the low horsepower, the low power, low pressure stuff is getting somewhat replaced by electronic stuff. So the hydraulics is going to be needed for the higher pressure stuff. So that's going to go higher. So
Special thanks to the guys from HydraForce for inviting us out, for bringing you along on this journey to come out and check these things out. I don't know if you're as impressed as I am when you look at the amount of engineering and work that goes into a big manifold like this. You know, it is the heart of your machine at the end of the day, and it's really cool to have some kind of appreciation for the knowledge and the engineering and all the work that goes into creating and developing this stuff. It's really cool, and it's also really exciting to see the future that we have out here for machinery, right? By no means are we at the end of the innovation that can be done to the equipment that we run day in and day out, and it's really cool to see what these guys are doing. So thank you to HydraForce for inviting us along. I hope you've enjoyed the video.